Before I get started today, I just want to say thank you for taking the time to come out and be part of today's event. Now, Crafter Software is a software company that builds award-winning open source products for managing and delivering digital experiences. We build web content management systems, high-performance content delivery engines, or dynamic content delivery engines, personalization engines, social platforms, and more. And we build these platforms out in the community with open source and both with open source and as open source. And at Crafter, we really believe that open source is the best way to build and distribute software. And what we sell is value around that support, that software, like support and training. Now, companies of all sizes use Crafter today to deliver rich content applications and digital experiences. And you can see just a few of the medium to large size organizations using the software, just to give you some context about some of the things that we're going to see today and who's using it. Now, this is our agenda for today, and we're going to basically briefly explore the role of content in our applications. Then we're going to discuss some of the challenges that we face related to content and applications. And then from there, we're going to look at best practices and what we think is a platform that solves some of these challenges. And we're actually going to build out a sample application with that solution. So let's talk about that sample application real quickly. It's going to be a simple game of memory like the one you played with as a kid, where you try to find the matching pairs in the least amount of moves. And the requirements basically are that we want to be able to deploy new games at any time once the application's been deployed. And so without having to do a deployment. We want to be able to write names and scores into MongoDB so that we can ultimately create a leaderboard. So these are the basic functionalities here, in addition to just the gameplay itself. And we're going to build the platform with the following technologies. So we're going to use modern front-end tools like AngularJS to build out the UI. We're going to be using Spring and Crafter as the foundation for our server. And we're going to be using Groovy to create the services and the controllers, as well as any libraries that we need to create. Okay, now our claim here is that when it comes to multi-channel content-oriented applications, there's no faster way to build and deliver these applications than with the foundation based on Spring and Groovy and brought together by Crafter, which again is this open source platform built on top of Spring for your content-oriented applications. What you want to compare this to are other frameworks like Node.js, Ruby on Rails, Grails, PHP, and so on. The major difference here is basically in the architecture. This platform is just a better fit for these content-oriented applications, and as you're going to see, although it's optional, we're going to bundle in support for authoring that content and deploying it to your servers. But before we get into that demo, let's take a step back here and set up some context. And so what I want to do is start by talking about the importance of content in our applications. And when we look at all the different types of applications out there, and let's just consider a few here, like social applications, photos, video sharing, communications platforms like WhatsApp, email, and Talk, to control interfaces or what we sometimes call human-machine interfaces that let us interact with our homes, cars, and other systems, to banking and finance platforms, to travel platforms like Expedia, Kayak, airline sites, hotels.com, and other booking platforms, to games, to more traditional sites and platforms like corporate portals and websites and kiosks. What becomes really clear here is that it's not just about features and the user interface. What we see is that almost every kind of application today involves some kind of content. And if we really think back to those examples that we just looked at, what we'd see is that it's more than one type of content. There's content that's part of the application's purpose in life, the products, the locations, the game collateral, the articles, and so on. There's marketing collateral, like and content that marketing would like to put on the peripheral of the user experience. And there's sometimes user-generated content where the users themselves are providing the photos, the videos, the blogs, the comments, and other content. And the other thing that we see when we consider all these applications is that there's a lot of multi-channel out there. Many of these applications are available on different platforms, like a traditional website, and also a native experience. So what are the challenges that we face when we're building these kinds of applications? Well, there's a couple different types of challenges, both technical and some not. And I'm just going to cover some of the development challenges first. So let's take a look at those development challenges. The first challenge that we see is that development is slow. And that's not our fault as developers. The fact is that development is just really hard. And although the industry often compares us to the building and construction industry, development is nothing like that. It's not nearly as predictable. We're not dealing with as many established patterns, as long a history, or even some of the physical constraints that they have when they're building. And as a result, even the most basic applications can take months to deliver into a production-ready state. And most applications take more than 18 months or more to fully develop and deploy. And we all know that saying here that time is money, and it's absolutely true. I mean, we can see that from this diagram here. And so anything that we can do to speed up development for our multi-channel content-oriented applications is going to be a huge win for us. Another major challenge is scalability of the applications. So unless your application is truly self-contained and it runs purely on the client, like let's say a calculator or something, then you have to worry about how your application scales. The question is, how much horsepower are you going to have to put in your data center in order to provide your users with a great experience each and every time they use your application? And the last challenge I want to talk about that developers face is getting updates to the users. Web applications solve this problem, right? We could just push a new application out. But the multi-channel world that we live in today with wearables and native experiences brings this problem straight back. And even when we develop new features, we're not able to get those users to download and install the latest version with some kind of predictability. We can't force it. We can't push the update. So we're looking for ways to do that. Now, once you add content to the equation, you get a whole new class of problems that really rear their head. And so I want to highlight some of the common ones that we face with our content-oriented applications. And the first one is that content creators and developers are not the same. Of course, the picture kind of shows here they're typically different from a Myers-Briggs perspective, but more importantly, they need very different tools. They have a different process, and generally speaking, they operate on completely different life cycles. Okay, and the second challenge that we see is that content, in a way, in a really real sense, is a product of its own, and it really needs to be externalized. So these 2 points seem fairly obvious, at least to me, and I think probably to you, yet most organizations suffer from the fact that getting new content to their application involves some kind of deployment, and thus it involves development staff and operations staff. And sometimes that means updating your content or updating the application itself, like by doing a deployment, and sometimes that just means updating a database. But the fact is, it doesn't really matter what kind of update you're having to do. If your content team isn't completely independent of your technical team, then you're facing that first challenge. And if your content isn't independent of the application, then it can't easily be worked on independently of the application. And in some ways worse, it can't easily be reused across existing or even future channels that you need to support. And there are other concerns like translation and so on that having your content externalized can really help out with. Now, the next big question is, what can we do about it? And there's a lot we can do. And the first thing I want to do is just cover some best practices. And then we're going to take a look at a technical solution and ultimately, get into the demo. So let's begin with those best practices. Now, the first thing we need to do is we need to, when we start building our applications, we need to understand the requirements. And that's clear. Everybody knows that. That's where we begin. But what I want to say here is that one of the biggest questions we need to answer is what kind of platform are we going to develop with, and what kind of platform are we going to develop for? And we all know today that users of our applications really want to be able to use their applications not just from the desktop, but also from their tablets and smartphones. So we need to understand if we're going to build a client, if we're going to build clients for our application, if those clients are going to be purely native, if they're going to be some kind of responsive and adaptive web application, or if they're going to be some hybrid of the two solutions. Now, the way to make this decision is to look closely at what we call the 3 C's. And the 3 C's are, the first one is use cases. And that really means that we're looking at what do the users need to do. Will they need the device-specific features like the camera or the accelerometer? The next thing we want to look at is what's the context? Where and how are the users going to be using the application? Will they be online all the time? Or will they be offline sometimes? Will the users be a consumer of the content in the application, or are they also some kind of producer? The question is what approach would support the best user experience? And a classic example might be here with this is GarageBand, right? If you're a producer of music, then you need that really rich native tool to produce that music. Another question is what kind of content is the user consuming? Is it rich animated content? Is it video? Is it gameplay? Is it images? Is it articles? Different content really requires different approaches to the application. Now, the point is that choosing the right approach has 2 major impacts. And the first is how happy is the user with the experience, and the second is how quickly can we develop the application. It's no secret that native applications tend to provide a better experience when they're properly built, but they take a lot longer to code, and getting users to download them and update them on a regular basis is a challenge. Okay? So you want to think carefully about this. The other thing you need to make sure is that whatever platform you choose, it needs to support both native and web applications, because eventually you might find that you need to adapt. Now, the next best practice is to get the right technology at the right layer of your application. And I bring this up because over the years I've seen a lot of architectural choices that I just don't agree with. One that's become popular today is JavaScript on the server side. And, on the face of it, I don't have a problem with scripting on the server side. Scripting on the server side is a huge advantage, but for me it comes down to the right motivation and then the best technical fit for the problem. And a lot of people that advocate this JavaScript on the server side do so because it's a familiar technology and it creates one programming model between the client and the server. But I disagree with this motivation, and I think it leads ultimately to poor solutions because it's not the best technical fit for a whole host of reasons. So when you're picking your technology for your persistence, for your business logic, for your scripting, your UI, and so on, you really want to consider your motivations for picking that technology and make sure that great technical fitness is a major part of that concern. And this brings me to the next practice, since we've been talking a little bit about scripting, and that is, if you can enable scripting, then you should do it. Using scripting technologies generally makes development faster, it's more pluggable, and it usually means it's much more easy to update the software. We're going to see some of this in our demo today. And for the most part, choosing scripting languages and templating languages over compiled platforms usually involves some kind of decision about performance. And here I think Groovy has a tremendous advantage over all the other scripting languages because it provides all the compelling scripting features, but it can be compiled down to the native code for the JVM. Now, the next best practice is to push all the heavy lifting to the server. We see this pendulum swinging back and forth every few years, but in a multi-channel world where you've got lots of different types of clients to your application, the best practice is to push as much of that logic into the server and have a common layer of services that allows you to build really thin clients, both native, web applications, and so on. And so again, you want to centralize your business logic behind the server, and you want to just focus your UI, your clients on the user experience. And our last best practice is all about architecture. When it comes down to it, what makes a platform successful is always how well its architecture is held up to the test of time. And certainly when we're talking about our ability to scale and meet the need for the demand for data and processing, it all comes down to the architecture. Good architecture cleanly is really all about cleanly separating your concerns. And a good architecture does that by compartmentalizing different concerns into their own layer. And by doing this, we enable ourselves to create simple solutions for each problem space. Now, specifically with content-oriented applications, your major layers are going to be the separation of presentation from business logic, and your business logic from your data and services tier. And that's typical, right? That's common. That's MVC kind of thing, kind of patterns. But you also need to cleanly separate your code from the content, and we'll also need to separate the concern of authoring and delivery. Okay, now we've been through some of the challenges and some of the best practices, and what I want to do is get into a solution that'll help us overcome these challenges by bringing some of these best practices to bear, and then we're going to jump into seeing this in action. So what we're going to do is we're going to begin with an architecture where, like we described, we have a thin client layer, and we could be doing native applications or web applications, or probably both. And it's important that we don't duplicate anything here. So we're going to push all that heavy lifting down to the server. And this is going to make it much easier for us to handle the various channels, but also to scale our application. We also see here that we're going to pull the content out of the application and put it on the side. And this is the key, one of the key components of our architecture, that we externalize the content from the application, and that we be able to deliver new content to the application and to its users anytime we want without a deployment. We also want our solution to perform, so we're going to build on top of this previous slide where we push the meat of the application to the server, and we're going to, basically show that we're going to use Java for this, because Java is a very performant platform. And of course, on a spring webinar here, we're kind of preaching to the choir. But also, we want to persist data. And if we need to persist data and do queries, then we want very fast and scalable technology. So relational database technology has long been a standard for persistence, but in the last 3 or 4 years, we've seen the industry really wisen up. And if we don't need subqueries and we don't need to support certain kinds of relationships, then as an industry, we've found that different types of persistence tiers like MongoDB or Apache Solr are frankly faster, they're much easier to scale, and for some tasks, they're just much more powerful. They provide out-of-the-box capabilities that databases don't. Now, we want to be able to code quickly. And so, we may even want to be able to deploy plugins to our application, and we want to be able, we want to make sure that we can build our applications quickly and very cleanly. And for us at Crafter, this means using Spring. So and we use Spring for all of our applications. And the Spring Green framework, Spring MVC, and all of the power that Spring gives a Java developer makes it the ideal platform to help speed up your development while maintaining a clean code base. And now, what we want to do is be able to deploy code quickly. And we may want to be able to, we also may want to be able to deploy plugins to our application. And for this, we're going to introduce scripting technologies. Over the years, the application space and the game industry and other software industries have really found scripting to be a game changer. Spring really easily integrates with scripting technologies, and our favorite is Groovy. It's a perfect blend of the scripting technologies that you're used to, like dynamic typing and closures, but brings the power of Java. You also want to make sure that your presentation tier is easy to maintain and manage, And the way to do that is to separate the code from the actual presentation. And you do that with templating. And in the Java space, there are two major templating languages that really stand out, and that is FreeMarker and its older cousin, Velocity. Now, templating languages like FreeMarker integrate seamlessly with the Java and Spring stack, and they really work well with the Bean standard. So we can very cleanly separate our code from the rest of our presentation code from the rest of our stack. So now before we move on to the demo, I just want to talk a little bit more about scripting. So when I'm talking about scripting business logic, I'm specifically talking about the ability to script user interfaces. So we might want to be able to put business logic behind a page or behind a component, and we want to do that by just dropping a script that can talk to our business tier and can ultimately provide a model to our view. And we also want to support RESTful APIs, because we're going to support native clients, we're going to support JavaScript-like applications, and so we need to be able to return RESTful responses. And so the best way to do that, again, in the scripting technology, is to have the framework do all that translation to the wire protocol for us, but let us code the business logic in a script that can then can talk to our model. So we're going to see that as we get into our demo. Now, for the most part, when we think about the platform, the server and so on, we're thinking about the delivery component of the system. But in our case, we have content to deal with. And so I've reintroduced this content here on the left-hand side so that we remember it. And we remember that needs to live outside the platform. In fact, not only do we need to think about how we externalize the content from our application and how we're going to deliver it, but we need to think about how the content itself is created. And digging into that, that concept really brings us to the constituents around the content. So there are three types of constituents in a content-oriented application. The first is the users that consume the content, and the second is the developers that build the applications that deliver and interact with that content, and the third is the authors who create the content. And the fact is that each of these constituents need a different type of environment for their needs. Developers, of course, need IDEs, they need testing frameworks, they need tools like source code management to help them create the applications. Users need a high-performance multi-channel delivery tier to be able to consume and interact with that content that's scalable and performant. And authors need tools like preview and in-context editing, and what you see is what you get type of interaction to create the content and the ability to workflow that content and publish that content at any time. And that's the architecture that we ultimately need here. That's the separation of concerns. And if we had to build this platform from the ground up, it would be a lot of work. So even starting with all the power that the Spring family gives us, we would still have a lot of infrastructure put together. And that's because this content adds a lot of concerns, like authoring. And so fortunately, that's where Crafter really comes in to help us out. Just like Spring, all of our components are 100% open source, and they're built on top of the foundation that Spring provides. So working with this platform is something you're going to be familiar with. And in fact, the architecture that we're looking at here with Crafter is the exact architecture that we've discussed. Spring MVC sits at the core of both of these applications and allows you to add your own components to these systems through plugin frameworks or through Maven archetypes and so on. And that's sort of a more advanced topic. We won't have time to get into that today. But you can take advantage of all the things that Spring has to offer. And more importantly, Crafter Engine, which is just a Spring MVC application, is built and ready to deploy to consume content outside of the war. Crafter Engine reads the content from disk. It can read content from Apache Solr. It can consume those objects and then make it available to your controllers and to your presentation. And then looking here back at the architecture, we see that authors need their own tools to create and workflow content. And Crafter Studio is exactly that tool. it's a complete authoring platform, a very rich authoring platform, built on top of Spring MVC. It allows authors to manage and create and publish digital assets. And these two platforms are independent of each other. You can use one without the other. And that's what we're going to do in our demo. We're going to start on the engine side just as a developer, and we're going to create an application. And then ultimately, we're going to show how we can manage some content in that application. So now we're going to jump into our demo. You're going to remember that we're going to be creating a game of memory, and our content is going to be the games. So we're going to want authors to be able to create new games and deliver those to the application. So let's start just by building the application. And I've actually already started to do some of that. I'm just going to refresh here. And so here you can see, really, okay. Okay, Gods of Demo. What's going on here? Let me see. Let's just jump in here. And I think I've introduced a little JavaScript error, so let's check that out. I apologize. That's really weird. So I'm just going to pull this out. And let's see what the issue is. If this is the only change we made. The other thing I'm going to have to do is just look at the logs there. Look at the Firebug. See what the problem is. So what is it saying? Yeah, it's right there. I'm sorry, guys. I made a change at the last minute, and unbelievable. Okay, well, let's see. It seems to be happy. It's just a caching issue, I guess. So here's our game. I apologize for that. And you can see it's just memory. So we can flip over the cards, and I can just kind of go through here and, find a matching card. And when I find a card that matches, it stays turned over. Now, this is just an Angular JS application. Let's look at that quickly. Let's just look at what this page is. So here you can see, it's just a standard HTML page with some Angular templates. And it's ultimately calling in this app.js. And let me just make this a little bit bigger for you. And I'll just click on this so you can see most of what's happening here is all happening on the client side. And it's just an example application. You can build with any framework you want. There's no need to use Angular. And you can see here that one of the interesting things that this application does is it makes a service call to itself to get cards. And ultimately, you're going to find is that that's using Crafter's content services to pull up these games, and that's how we're going to dynamically pull content in. But the question is how did we get to the point where we could actually deliver this page? So what I'm going to do is step back now that we see the page here, we've seen the code. I want to show you how we got there. So let's just close this. And what I'm going to do is go into just my machine here, and there's Apache Tomcat. I'm going to go into the web apps folder, okay? And the war that we're running is the root war. You can see that that's the context here. And there's nothing special about this root war. This is just Spring MVC, and it's using the standard dispatch controller and so on of Spring MVC. But we have some of our own plugins here. And again, you can bring these into your application, or you can use our war out of the box. One of the key things here is you could just use this war. Your whole application is externalized outside of this war. So let's take a look at that. So this is the war. It's just like an engine. You can think of it as an engine. And the whole application, now we don't need this window anymore, the whole application can sit somewhere else on disk. And that's going to be really important because we're going to deliver the scripting and we're going to deliver the content to the application at any time we want. And so you can have any folder structure that you want where you ultimately you're pointing engine to some folder, and I'm pointing it to this work area. And inside of that work area with Crafter Engine, we have a set of folders, and these are these are there for you by default. It's kind of like a rail. so to speak. And each page that you want to create lives under site and then under website. And you can see here that there's an index page, and that corresponds to the page that we see here. So let me just open up this index page here for you. So let's just drag this down. And I'm going to show you this little XML document. And you can have any tags in here that you want. This is basically where you can put content. You can describe content for that page or that component. But the key thing for a page is that you tell it what kind of page it is. This is going to be important when we try to hook up our controller. So in this case, it's entry. And that you tell it what display template to use so it knows what presentation, what view to drive. Okay? And then beyond that, all these other properties are mostly concerned with driving content in the application. So if we want to, edit that, now that we've been here, let's go to, again, so I can use any tools I want to modify this. So I can actually back up here, back out of static assets and go to site, and then website. And we can edit that index XML. And let's just say, for the sake of fun here, we can say spring. We call this content spring, and we could say hello world. Okay, and then we'll just call this close the spring tag. Okay, so now we've added this content. We'll see that in just a bit. Now the next thing we're really interested in is where does this template come from, or what's the view? How do we drive that AngularJS, that HTML to the screen? So we know that the controller is seeing this XML, it's making a page, and then it's looking for this template, and it's going to be able to drive this other content into that template. So let's go look at this templates web entry.ftl. So I'm going to say close here, and I'm going to move over to templates and then web. And here I'll see entry.ftl. So nano entry.ftl, and here you can see this is just our markup. It's exactly what we see printing out in the HTML, and we can actually use the variables that we put into the XML, which ultimately would come from an authoring environment, maybe not so much by editing XML. But the point is that you see that there's no magic here. You could actually code this stuff and drop these things by hand. So here we can say $model.spring was the name of our variable, and then close this H1, and then save this content. And now if we go back to our screen, what we should see is an H1 with our hello world content. And ultimately we can go back into that XML and just keep modifying that content. And you can see the basic mechanics here. Okay, now what I want to do is actually in the next 30 minutes here or so, I want to add the features that we talked about. I want to add a leaderboard, which means we're going to add a new page. And a new set of templates, and we're also going to have to write the score of the number of moves that it took to solve a number of cards. So we're going to have to build some services and so on, some controllers. So you're going to get to see how all that works. So let's start. The first thing we want to do is we want to build a new page. Let's say that we want to create something at leaderboard. And if I go there right now, it says, oh, this is a 400. This page doesn't exist. Okay. And this can look however you want, but this is just a little demo app here. And so let's add that page. And so as you saw before, to add a page, all we have to do is go into our, onto our drive, find the site, go into the website folder, and basically create a new folder and that folder will correspond to the URL. So I've actually staged some of this demo here, some of the code and stuff here over in Spring Webinar. So I'm going to pull that up too. Here we go. And I have the leaderboard folder and that index XML. So let me drop that into our environment, and then we're going to, let me just organize this a little bit. So on the left is the stage code. On the right is the disk that contains our application. And all I'm going to do is I'm going to take the page and the index XML and drop it into our application. And then let's go in and look at this index XML. So here, if we view this in an app here, we can see that the content type is going to be called leaderboard. Okay, again, it's going to be important when we get into controllers. And the template is going to be called templates web leaderboard.ftl. So the system will expect that FTL to be there. So now this page should be here. I dropped it into the framework and it should just be there. It's this easy to create a page. Now the system is saying, okay, that page is there, but I don't know how to render the view. And just to make this clear, I mean, we can just play with this just a little bit more to illustrate the point. I can change this URL to anything I want. I can say -A, and now I need to go here, and I can no longer get to this page. I have to go to -A, right? Okay, so you get that. All right, now let's just change this back and refresh. Okay, so that now we're at a point where we need to put a view. And we said that that view was going to be in the templates directory under web, and it was going to be called leaderboard.ftl. Okay, so let's add that. So I'm going to go out to demo, and I see leaderboard.ftl here. And I'm just going to drag that into my environment. Okay, and now let's look at that. What's going on with this piece of code? Okay, for those of you not familiar with FreeMarker, it's very, very easy. It supports loops and if statements and so on, but ultimately what you're doing is just describing the markup. And here you can see, we're basically going to print out H1 that says leaderboard. We're going to have a table with a header, player name, and scores, and then we're going to iterate over leaders if this variable is available and print out their name and their score. The key is, where is that leader variable going to come from? And we'll get to that in just a second. Okay, but now that we have this template here, we should be able to go to the page, refresh it, and see our leaderboard. It's that easy to put up a new page. Now, this is a very simple page. Your markup is going to be a lot more fancy, but the mechanics are super, super simple. Now, the question is, we want to read and write some data. So first thing we need to do is we need to actually have data to read. And I mentioned in the beginning, we want to write data to MongoDB. And I want to show you how easy it is to create services that can do this. So in our game world, what we want to do is at the end of the game, we want to write your name and your score and so on into our database. And so what I've done is I've set up MongoDB, okay, and here we have a book collection, and you can see this is the database called Groovy Book, and there's no collections in here yet, okay? Now, what we're going to do is we're going to go in and we're going to modify this JavaScript application at the end of the game to write content. And actually, if you saw what we were looking at in the beginning was that there was some JavaScript error, and it was really a caching error. But I was basically turning on the ability to write. So all I did was go in and modify the application so that it's going to write to a service called Service Game Leader Create JSON. Okay, that's the service we're going to post this data to. Now, remember, we're already reading content from a service called Services Game Cards Get Cards. So let's look at this service first, and we'll build the other service. So I'm going to go into this, go onto our platform where we have our system. I'm going to go into this time scripts, and here you see a couple other aspects of the Rail. There's just some default folders here for you. There's a libraries folder where you can create your own libraries. There's pages where you can create controllers for pages, and there's components where you can create controllers for components. And then there's a REST folder where you can very easily create REST services. And that's what we see here. We see a REST service on the platform. So, for example, if I were to just take this call here, right, and put it on my URL. So let's close this now and go back here. We'll just put this on the URL and make the call. You can see that I can get this some kind of response here. So I change this to 55. Maybe I get a different response. So I'm querying. I'm making a call, and that service is making some decisions for me. So let's look at that service, how we got there. So the URL is game cards get cards JSON, and then you can see I can also ask for XML, for example. Okay. Now, how does that work? Well, inside of REST we have the folder game, and inside of game we have the folder cards. So under this REST folder, these folders are completely up to you. You organize your services however you want. And inside there, I have a little rail, which is a service called Get Cards. And there's my method, my HTTP method. This is a get. And if we look inside here, we can see what this does. And we won't get into this in too much detail, but you can see here what it does is it gets the age off of the URL, it creates a query, and then it uses Crafter's services to query the games that are available for that age range. Okay, so this is dynamic content that we're bringing into our application. And that's how we're actually bringing the content into the application. We don't have a lot of time to go over that, but all these services are built right into Engine for you, that Solr integration, that content integration, built right into this application right out of the box. Okay, now we want to build our own service where we can post the scores. And so for that, let's close this. What we're going to do is I'm going to drop inside of the inside of our application that a new folder, and these services are more concerned with the person who's scoring, not the card. So it's still part of the game, but it's not to do with cards. So we're going to create a new folder called Leader and drop inside of that folder 2 new scripts. And the one we're concerned with is create, and it's a post Groovy. And so let's open that up and take a look at it. So if we look at this, what we see is that this service simply gets a DAO, it inits it, it pulls some data out of the JSON that's being posted to it, and it calls a DAO and says, create a leader. Now, that DAO is mine. It's a library. And I did that on purpose because I want to show you how easy it is to create these libraries with Groovy. You can see how simple this code is, how much it resembles even Java, and how little code we have to write to interact with that DAO. But now let's look at the DAO itself, because this is where it gets really interesting. So if I want to import that library from scripts, libs, DAO, if we go back to that folder, let's keep this up on the screen. So just keep that on the screen for you. If I go back to my scripts folder, I see I have a libs folder, and then I have my HTTP, which is my little HTTP helper, but I don't have a DAO in there. So if we were to run this, it would blow up. I wouldn't be able to find this class. So I want to add that. So what I'm going to do is I'm going to go into oh boy, where's my DAO? Oh, there it is. There's my DAO. So I'm going to take my DAO and drop it. And now it's in that folder. And let's open that up and take a look. And so here you can see this is how easy it is to talk to Groovy. We simply declare that we're in this package, and then we import talk to Mongo. Then we import the MongoDB library. Nothing to it, right? Very simple to do in Groovy. And then we've created a DAO object with a couple methods. Init, so this just creates a database connection that's going to talk to that database we were looking at. And ultimately, we created a method for create leader and get leaders. And look how simple it is. I mean, literally, we say, take the information coming in, calculate a score, and then insert into the scores collection this object. So presumably, this code is going to create this collection for us, and it's going to insert whatever document we give it. And then when we want to get the leaders, we simply call dbscores.find, and we sort in a descending manner. Now, of course, your code can get a little bit more complex, but the basics of a CRUD application with Groovy are amazingly simple. This is all we need. And so now we have a service that relies on a DAO, so we've imported a library. We can really easily factor our code, and now we should be able to post. So let's take a look at our database. Let's confirm that there's nothing in there. Okay, and here we can see, again, there's nothing in that. There's no collection there. And so what I need to do is I actually need to go back to my application, and I need to finish a couple games to write a couple records. So let's refresh this, and I'm going to say, let's just kind of go through here and find some matches. Hopefully I can do this pretty quickly. Okay, doing okay so far. Wow, pretty good. So that's our first score. Let's go to the database and see if that's there. And we go here and check it out. and choose collections. And now we see a scores collection. So it automatically created that collection for us. If we look inside, we can see our first object. If we expand that, we can see that we had 4 cards and we made 5 moves. We made 1 mistake. Okay, let's play again. Let's just get another score. Okay, so I click on this. Okay, there's our unicorns, and okay, so there's our Zeppelin. I need to make some mistakes here so that we get a different score. Okay, now we've made a bunch of moves, and so now we know that these two are the same. And now we've got a different score. Okay, so let's look again to see that that's there. Okay, so we click here. Now we have 2 records in Mongo. So look how easy it is to write this stuff. And here our score is 20, and here our score is 40. So we have one score that's much better than the other. And now what the interesting thing is, well, can we go to our leaderboard and see this? So if we go to leaderboard, of course we don't have any, we still don't have any scores. And why is that? It's because when we look at that template that is driving that page, it's asking for, if you remember, again, let's go back out here. If you look at that template, it's asking for a variable called leader, and that variable doesn't exist, and we have to supply it. So what I want to show you is now how to create a controller. We've created services, but how do I create a controller behind this page? So to do that and supply that variable, what I'm going to do is I'm going to go into scripts, and I'm going to go into pages. And remember that content type name. That was leaderboard. And that's very important for us, because if we name our controller leaderboard, then that controller will automatically run for us whenever we render this page. So all we have to do is add a script called leaderboard inside pages, which is the name of the page type. And the same is true for components. And now let's look at this code. Here you can see this controller is really simple. Import my DAO, initialize it, and then get the leaders. And save that to model.leaders. So we're supplying that variable name. Now that we've dropped that code, all we have to do is go back and refresh, and we've got a fully working application. It's doing CRUD behaviors and so on. Now, that was really fast to develop that application, but now we want to enable the authors to do their work. And to do that, we got to give them that set of tools that they can easily work in. That's completely separate from the delivery environment. So again, you could use this engine to do just what we did, and you can even hand write the XML like we showed. But that's difficult to write hand code XML. So let's look at some tools that can make that easier for us and also enable our authors. So to show that, what I'm going to do is I'm going to go into back into my template here, and let's just close this. And I am going to turn on, we only have about 5 minutes to show this, but I'm going to edit this entry template, excuse me here, and I'm going to turn on at the bottom here our studio environment. Okay, so this is a little free marker tag that we supply. And this works in your authoring environment. Your delivery environment can be completely separate environment. But let's just save this file. And now when we refresh here, we're still signed in, which we're not. So let's go ahead and sign into the authoring environment. I'm just going to log in now. It's permissions. Of course, your authors, you want to have permissions. So let's go to memory, and let's click on our home page. And now we see authoring tools over top of this game. Okay, and the neat thing is that they can see the same application on different channels. And right now we don't have any responsive design going on here, but the tools provide the ability to see those applications on different channels, makes it easy to author content, and they can go in and they can edit this content. So for example, they can also, they can edit the content, which we'll see in a second. They can also switch between games. So for example, I can switch like the type of user that's using. I can test different types of users. and I can see, different games. Now, here we saw, zeppelins, we saw unicorns and dinosaurs and so on, and I want to show you just a quick edit of that content. So what I'm going to do is I'm going to go into the authoring tools. We're not interested in editing the pages that we created. We're actually interested in editing some of the content that the application's running. And for that, we have games. We just created that idea. And there's the fish demo and the kids stuff demo, two different games. And we could add another one. So that's the point. We could add more games if we wanted to. I guess, so a second here. Or we can just edit an existing one. So I just want to show you this other game here. So let's choose this other user. Different users get different games. The older person gets more cards, right? And they're fish. Just to set the context there. I know we're running a little low on time, but I'm going to switch back to this other user here, and we're going to work with this simple card set. And all I'm going to do is change that card set. I just want you to see how easy that is. So go into Components, go into Games, and as an author, I just right-click here and say Edit. And now I'm not thinking about, wrong game. Excuse me. I'm not thinking about the application anymore. I'm just thinking about the game that I want to create. So here I can see all the different cards. I could add new cards, or I could just replace existing cards. So let's change this dinosaur, for example, and replace it with, a rocket. Okay. Let's upload that content into the system. Let's, change this horse and replace it with the Kronos here guy. And we could just kind of go on and on. I just want to make enough changes that we'll be able to quickly see it. Once we've made our changes, we save it, okay? And now in our preview environment, before we even deploy the game, we can actually test it. So we can go and look for, there's our Cronus card. So, we've already made those changes. We should be able to find, the rocket that we made. So you can see that it's really easy now for authors with a rich set of tools to update their content. And I'm just going to show you how rich these tools can be. It doesn't have to be just these simple edits that we're doing. I'm going to switch to a completely different kind of site and take 2 minutes here to show you that. So I'm just going to jump over to this other site. This is more like a traditional website called Rosie's Rivets. And here you can see that this site is composed of a lot more pages. And if I click on, say, the home page here, then I can browse around the application through its navigation and get to the women's page and so on. And this looks a lot more like a traditional web content management system. But the point is that these tools can take you really far. You can actually, go into page components, for example. You can build your application out of components and easily move these things around from one position to another. So, for example, we can, maybe swap these two components. And it's just really easy for your authors to build out these experiences and then, to test them across different channels. So, for example, this is a traditional desktop, and this might be a mobile experience. So you get this idea that these can be completely different experiences depending on the channel. And whether your application is a website or it's a game or it's any of those examples, it really doesn't matter. What you're trying to do is make it very easy to deploy content into those applications, make it very easy to set up. So what I want to do now is hand things back over to the Spring team to take some questions. And I'm just going to put our presentation back up here and put up some key points here, which we'll go over at the end, right at the end. But for now, I'm going to put up some contact information. I'll talk about that in a bit, but let's take some of your questions. Hi, Josh, you there? Okay, while we're waiting for Josh, let me just kind of cover some of these key points here that we saw. So the first key point is that the right platform for the use case makes development fast, okay? And so we saw just how easy, because we're talking about these content-oriented applications, because we have these concepts of pages, of components, already of services, we already have ability to access that content, to get that content from outside of the WAR file. The development is extremely fast. And because it's possible to access that content outside, we can very easily put rich content authoring tools on top of it, which makes authoring content very easy and independent. We also saw that there's separation of concerns here. There's a very separate authoring platform, a very separate delivery platform, and you can choose to use one or the other of those or both. And you also saw a very clean separation between code and content. Another key point here is that we want to externalize that content, and I think you saw that. All the content stored in XML or as images and so on, it's all completely outside the application, and we can modify it. We have the rich integration with the content authoring tools called Crafter Studio, and that's just out of the box. If you're using Crafter, which is built on top of Spring, you're going to get not only that engine, but also these rich authoring tools. So Spring, Groovy, and Crafter for content-oriented applications, especially those that are multi-channel, is definitely the way to go. Josh, are you there?
Hey, Russ, this is Amy. Hey,
yep.
So there are a couple of questions from Vikas. Does the change done by the author persist across sessions? Not sure if you'd answered or had seen that question, but that was the question that came up.
Sure. So yes, the changes that are made by the author. Actually, one thing that might be a little bit confusing in the demo is that we showed kind of like one environment, one URL. Typically, you'll have your authoring environment, and it has a preview server, a preview version of your application, and your authors are, they're making their changes and previewing that content, and that's that content is persisted into a content repository and is previewed through that preview server. And then when once they put it through workflow, it's then pushed live to some delivery infrastructure. It's still Crafter engine, but it's probably much more scaled out because the SLAs are different, because the load that you're going to take is different. And so that content is then pushed to that server where it's just pulled off of disk and out of memory and out of Solr and so on. But it's certainly persisted across sessions. It's persisted in a repository, and it's persisted as XML.
Okay, next question is, do all of the Groovy scripts run in one single thread?
Do they run in one thread? For a specific request, they run within the thread of that request. So I think the answer, and this can be a little bit more complicated, but I think the answer is yes. That's sort of the servlet container model. And so for that specific thread, they do run in that single thread.
Okay. Same person is also asking for a comparison between Groovy and Node.js.
Sure. So, there's quite a bit of differences on the language level. Just the actual language. They support a lot of the same concepts. And I think, we probably don't have enough time to get into that. The big difference here for us, why we chose to use Groovy, is because on a Java platform, it's much more performant. It's highly integrated with the Spring family, and very, very familiar to the Java space. A lot of people use Node.js because it's sort of like the same technology on the server and the client. And I think when we really look at who's doing what, it's often not the same programmers, and that really doesn't buy you a lot. It's great for demos, and I know that that's a popular platform, but we think this is a much better approach for the Spring community.
Okay, great. Another question. This is about the source code from your presentation. They'd like to refer to the code source that you had in the presentation. Will you be posting the presentation somewhere they'll have access to it? Absolutely.
We can post the presentation. We can make the code available to you. We can get that information from the Spring team and forward that on to you. I will also be doing a series of blogs on this, so you can look forward to that as well.
Fantastic. All right. Well, it looks like we have exhausted the QA. So I'd like to thank everyone for joining us today. Again, the webinar is recorded and it will be available from the Spring YouTube channel. We definitely recommend that you subscribe to the video option or add-on feed to receive the latest postings. And that's at spring.io/video or spring.io/blog. And we will post that within the next 2 weeks. Russ, do you want to share anything before we sign off?
Sure. So just what's here on the slide, you can download Crafter at craftercms.org. It's 100% open source. It's based on Spring. It's a great platform. All the documentation is available on our wiki. You can find more information on our blog site. Also, we're going to be at Spring 1 in Dallas, and we're going to be at Java 1 out in San Francisco in September. So if you're there, come out and see us. We're really looking forward to meeting you, talking to you, and finding out more about what you're trying to do with content in your applications. And the final thing there is if you're looking for any kind of resources, additional resources, we have all kinds of our own recorded webinars and so on, or you're looking for some kind of support around this, then you can go to craftersoftware.com to find out more about that. And other than that, just thank you for attending. I really appreciate your time.
Fantastic. Thank you, Russ. Thank you, everyone. Have a great day.